All right, I'll get started so we're not short on time. I'm Bruno Aziza, and I'm very honored today to have Hiren talk to us about his experience at Home Depot on Beyond Big Data. Hiren has worked at Home Depot for over 10 years now, so you could say that he knows everything about Home Depot. Who doesn't know Home Depot here? Everybody knows Home Depot, and you've probably bought something from Home Depot. And so what he's going to share with you is the best practices that he's laid out across this 10 years of work. There's a few things he told me about his personal life that he doesn't want me to share with the audience. I'm not going to do that right away. However, we want to make sure that this is as interactive as possible. So while Hiren has a set of slides and so forth, what we'll do at the end, I'll walk over with this microphone so you get to ask your questions. In fact, he was at our party yesterday and he was hanging out with the Canadian Tires guys and shared a lot of his best practices. So what's great about Hiren is he's got a lot to share with you. He's going to talk about supercubes. He's going to talk about biking and how that relates to Hadoop. It's a great, interesting story, but we also want to make sure that you guys get to engage with him and get to ask their questions. I know everybody's shy, so what we'll do is there will be rewards given to people that ask questions, and they're all in this bag. Okay, so that's an incentive that I could put in front of you. So with any further ado, thanks Hiren for taking the time. Help me welcome him to this presentation, and let's get rolling.
Thanks, Bruno. So hi, my name is Hiren Patel. I'm a software engineering manager at Home Depot in the Data and Analytics department. Thank you for coming to this talk. I'm pleased to share our journey to self-service analytics on Hadoop. At the Home Depot, we live by a simple premise given to us by our founders. Put customers and associates first, and the rest will take care of itself. To give you a little insight to our scale, we have 2,200 stores company-wide with 385,000 associates. A typical store has 100,000 square feet of retail space, and within that store we'll have about 35,000 products with an additional 1 million products available online. In 2016, we generated $94.6 billion in revenue, $6 billion more than the previous year. On a quarterly basis, my company posts an infographic like this one right here on our investor relations site. It's meant to simplify our results and communicate key takeaways from our quarter. My customers are approximately the 3,000 leaders and analysts at our corporate headquarters and 15,000 leaders in the field responsible for driving these results. Our BI solutions allow these individuals to understand how their particular area of the business is performing and how it fits in with the overall picture. Moreover, on a weekly basis, leaders conduct reviews with their teams On a weekly basis, leadership teams conduct performance reviews with our data and BI products. So in turn, they prioritize actions to the rest of Home Depot systems to ensure the right product is on the right shelf at the right time. The goal here is to make sure frontline associates can focus on taking care of customers while we're focused on ensuring that capital is allocated effectively to help drive productivity and efficiency. To help support them, our department attempts to absorb as much complexity as possible so that when a leader in finance, merchandising, and store operations sit down together, they have a singular view of the truth. In order to do this, we work with our product owners to understand the most appropriate information to show to users based on the context of the question. So the next couple of slides attempt to illustrate this. So let's assume you're the merchant over Power Tools. You have a review with finance later today, and you're responsible for sales, margin, and turns for that product line. One of the questions that you're probably going to have asked to you is, what is your quarter-to-date sales? The next slide will show what decisions we'll try to make on your behalf to get you that result. So the metric is sales, the time period is quarter to date, and let's assume today is December 13th. So since fiscal November is complete, the best possible information that we have that we can provide to you is audited store class month sales. And so we'll go get the information from November 27th for you. And then we're inside the third fiscal week of December, and we have an unaudited source from finance for store class week, and we'll collect the December 4th and December 11th data for you. And then after that, since we're inside a fiscal week, we don't have a financial source that's available, so we'll actually go to POS and roll up the store class day data and have the information for December 12th. We'll combine all that together and give you a composite result for your sales. So whenever you log into our BI products, there's only a single metric for sales available. Our folks are very busy and they don't have necessarily the time to understand, based off the context of the question that they're asking, what particular metric to pull into a report. So this will continue through the rest of the quarter, and by the time you get to the end of the quarter, your numbers will be as close as possible to what's going to be reported out to the street and rolled up from your perspective. So the next set of slides walk through the technology we've implemented to help serve these results to our customers. So our journey. In 2009, our department migrated from a traditional relational database system where the primary use case was sales analysis to an MPP data warehousing solution and paired it with MicroStrategy. The initial use case was to migrate store operations reporting to a centralized data warehouse. We also started building the foundations for supply chain, merchandising, and finance. So from our CIO's perspective, the request was to pull in the most granular information possible and every single table from the source and try not to leave a single table behind. Or sorry, try not to leave a single field behind. So by 2012, we got pretty good at this. We have a data warehouse that has about 200 terabytes of data. And we had implemented several MicroStrategy solutions. However, we couldn't keep up with the demand and the variety of requests coming from our customers. Moreover, our merchant community preferred to get their reporting in Excel. The reason for that is they'll get the data in Excel and they'll build out pro forma analysis, pro forma models to help drive business decisions going forward. So whether or not they want to take a markdown on a particular product, whether or not they want to increase the price of a particular product, and so on and so forth. So we built a cube for them. We put in the top 100 metrics, and it was available for the merchant community, which is about 200 folks in our company. In 2016, our data warehouse had grown. We are now having approximately 400 terabytes of data. There's about 8,000 tables, and we have 5,000 jobs loading data into it on a weekly basis. A lot of people really liked the cubing solution that we provided, and so we got requests year after year to add in information into the cube and start building a lot of critical mass around a singular self-service reporting solution. So by 2016, we had 2,500 users. On a weekly basis, you'll have about 800 unique users in our cube. There's about 1,200 metrics available, and in 2016, the size of the cube was 8 terabytes. The technology that we use is SSAS. So our customers are very happy, and they're getting the information they need from us, and they're getting the information in a timely manner, but our leadership teams are looking at the usage from both of our data warehouse, and they're looking at potential impacts to our cube and potential impacts to the team. So our rate of growth is not sustainable. What's going on here is that we have a data network effect. The more data we add to our data warehouse, the more valuable it becomes, and the larger the variety of questions we can answer out of it. So we're getting a lot of consumption in our data warehouse. If you look at, the data warehousing technology that we use, you can add nodes incrementally to it. But whenever you add a node to our data warehouse, we have to reorg the data, which requires downtime. Our primary customers are the operators out in merchandising store operations in the field, and downtime is just not acceptable to them. So what we try to do is we will try to plan out our capacity so that we can do a full server refresh. So we'll bring in a full server refresh of our data warehousing solution We'll copy the data over to this environment. We will dual load for a period of time, and then we'll test in the new environment, and then we'll do a cutover from our primary environment to our secondary environment. So a project like this is fairly complex, and it takes months to plan and execute. We have another problem, and that is that our supercube takes 16 hours to realign over the weekend. So every single week, on a daily basis, merchants and assortment planners will make changes to our product hierarchy. We'll hold those changes until the end of the weekend, or until Saturday, and then Saturday we'll realign our supercube to the new product dimension. Also, if we have a significant change to a metric or a lot of new metrics we want to add to our cube, it could take up to 3 weeks to reload it. The net effect of this is we're slowing down release cycle times from a development perspective. So we're batching cube refreshes. Since we have to incur a 3-week cost for a reload, we're batching them up to do them on a quarterly basis, as well as it's a scale-up solution. So our data processing node for our cube is a 64-core machine. It has 2 terabytes of RAM, and it sits behind some very, very sophisticated SAN. So whenever we make a change to the cube, we're analyzing the impact that it will have to our SLA, as well as we're monitoring cube growth because there's only so much SAN that's available to us. We have another problem as well, and that's superheroes. So we have a lot of complexity in a very tight area from an SSAS perspective. So what this means is you can't have a lot of individuals working on the cube at a single time because they'll step on each other. And moreover, the stakes are pretty high with this cube because of the amount of usage that we have. So you end up rewarding very, very smart people that have done hard work with more work. It's this downward spiral that happens where you always want to have the people with the most experience available to work on your cube, and these individuals then don't get an opportunity to branch out and work on other things, as well as it sets them apart from the rest of the team. So our leadership team saw that we weren't going to be able to make it to our next upgrade from a data warehouse perspective, and in 2015 they started working on trying to bend the curve as far as CPU consumption and storage on our data warehouse platform. In the meantime, I was asked to set up a team for our home services group. So traditionally, home services for our company has been underserved for a lot of different reasons. They generate about $4 billion a year in revenue. And from a data product perspective and end user perspective, it's a whole new set of folks. So the only data products that we would have crossover with the home services group and the rest of Home Depot or the product-oriented folks is sales and some basic product dimension information. So based on that, we decided that this was a good opportunity to develop a path forward, as well as by this time the leadership team had decided to, so as well as the leadership team started looking at other platforms to move workload over to Hadoop. A lot of vendors were brought in, and at-scale bubbled up near the top, and whenever I was asked to say, what solution would you like to propose for the home services group, I chose at-scale because I thought it was a good opportunity to start developing a path forward. So in the first half of 2016, we selected at-scale and deployed it to our lower life cycles and started to learn. We also integrated the source data needed for our core services metrics and started to build out our MVP data products. We held a pilot with our product owners in September, and every month after that, we would add an additional few users. Additionally, we worked with at-scale and Hortonworks on the features we needed to support our customers and stabilization. So this is the slide that legal approved for me to show you as far as my at-scale demo is concerned. we waited until fiscal 2016 was complete and we waited until fiscal 2016 was complete and started our rollout in February of 2017. So we had an issue with our rollout, and that was our end users were overserved with a lot of the legacy reporting they had to date. So I don't know if this is going to work. Oh, it does. Awesome. So this right here is our user count, that line right there. The orange bar is our query count, and the blue bar underneath, which is probably not going to work here, is our average query time. So what I was hoping for is that we would have organic growth on this platform. But what ended up happening was all the users came in at about the same time. And we expected to have performance issues with them, and we would expect it to be able, that we needed to tune, but not necessarily all at one time. So we worked with AtScale on reviewing performance issues, and the bulk of them were resolved by deploying AtScale 5.4 to our users. In addition, we had a very complex dimension that we didn't think would be used very often that ended up being used in almost every single pivot table and often being used twice or being misused. So we refactored that dimension, we built new templates, and we sent it out to our users. And so with the implementation of AtScale 5.4 and a new dimension designed to help simplify results or help simplify usage, our query performance came back down to an acceptable level. So today, we have AtScale sitting on top of Hadoop. That data never went into our data warehouse. Our business customers are happy with the solution that they have. They're logging in at 7 a.m. in the morning, and they're using it until about midnight at night because they're spread out across the United States. And they're using it about 7 days a week. And the leadership team that we have from a services perspective is very happy with us as well. Our SuperCube right now is about 12 terabytes because this past year our business users asked us to not delete the previous year's worth of data out of it. So we're holding an additional year's worth of data. And today it takes about 5 weeks to reload our cube. So going forward, a goal for me is to start refactoring our SuperCube so it's on a scale-out solution, and we'll be working with AtScale on that. And how we got these results primarily was team, frameworks, monitoring, and regression testing. So from a team perspective, the gentleman on the bottom left-hand corner is Doug. He's our product owner, and he sits side by side with us 3 days a week. We have a very, very close relationship with him, and he's able to come in and look at data anytime we need him to look at data. He's with us working on the weekends if we need someone to come in on the weekends and look at a version release that we're about to deploy. The two gentlemen, the person right next to Doug is Saravana, and then we have Nishant on the bottom right-hand side. So Nishant and Saravana have been on my team since about 2012. They're the senior folks on the team, and they primarily focus on building out data products. And the rest of the team is, for the most part, recent college graduates. So the rest of the team focuses a lot on the AtScale administration, the setup of the AtScale cube, support, as well as building out tools. So the way we have it structured is the two feature engineers work independently, and they bring in a junior developer so that those folks can start learning how to build out data products. And then we'll have another pair that we call, quote-unquote, Team Interrupt, that focuses on building out tools and support and upgrades. So this is kind of cool. In 2014, our team built out an ETL engine to process workloads through Hadoop. So we built, Home Depot has a proprietary Java compute grid, and we built an ETL engine that sits on top of that scales out for us. So every day we process about 2,000 jobs for our own processing, as well as some of our some of the teams in our group use this framework as well. So what we do is we built a DSL language for ETL graphs. So you can go into XML and define out an ETL process, and we have runners for Hive, Scoop, HDFS, and running queries on different databases such as Oracle and our data warehousing platform and the mainframe IBM. And from there, you can go into Maestro, and from a microservice perspective, you can have a URL for our data integration engine, and then you can have the property file that as a parameter that you want the data integration engine to run. So the data integration will start up, it'll go read the property file, and then start executing your graph on your behalf. And behind the scenes, what happens is it stores the results and retains the results in a database. So from a microservice architecture perspective, we have data services as well off of that database. And so what we're doing here is we built a data service for that, and we have a website on top of it. So people in operations who don't have a understanding of Hadoop can go in, they can go look at our jobs, they can monitor them. In our job parameters in the database, we can have plan variables for them, and we can have messages where we can bubble up error messages from our application. And we can also do some fairly complex orchestration of having parent-child jobs. So we focus a lot on health monitoring as well. So this is actually my living room. In the morning, I make myself a large pot of coffee, and I start going through my phone. I start going through Slack. So we have a canary query that runs against @scale every 15 minutes, and it just lets us know if everything in the stack is working as we expect it to work. Also, we're scraping the data service that runs the previous dashboard and posting the results over there to Slack so that someone doesn't have to log in via VPN, doesn't have to get a laptop, log in, and look and see how our batch is performing. They'll get their results directly in Slack, and that'll refresh every 15 minutes for you. So @scale has a set of starter Java code that you can use that will let you use its API, and we use that Java code to build out a regression testing tool. So from the time that @scale delivers a release, we could have that installed. Say if @scale deliver a release on Friday, we could have that installed on Monday in a lower life cycle, and then turn on regression testing for it and load testing for it. We can come in on a Tuesday, we can look at those results. We could do a bunch of manual checks as well on Tuesday, and then decide if that's something that we want to deploy into production. If it's something we want to deploy into production, we'll have a conversation with our business partners, and then schedule a change and deploy it either that Thursday or over the weekend. So this was very helpful for us because there were periods of time that we were running through stability issues. So we went through patches very frequently. I think there was one time that we ran through 3 or 4 @scale patches and upgrades in a span of about 2 or 3 weeks. So having regression testing and being able to quickly go through regression testing was important for us. From a lessons learned perspective, I have a very young development team on this particular @scale implementation. So what I try to focus on is having them develop a physical intuition of the technology components. So that just means, for me, having a mental model of how things work. So having a mental model of the data storage and understanding your partition scheme and understanding whether it's on Hadoop or more predominantly on our data warehousing platform, understanding if you're going to do a join, what's the locality of the join? What's the format of the data? From an end user perspective, if you have latency issues, is the data that they're accessing in memory or is it on disk? From a query plan perspective, if they wrote a query that they expect to run for an ETL process, did they go and check the query plan? Do they understand how it's being interpreted? And did they try a few different things out to see if they could improve performance? From a runtime perspective, do they know where all their variables are? Do they know what they mean? And do they know if they'll be able to sustain a failover, especially on from Hadoop? On an execution flow path, do they understand what the engine's doing? So for example, whenever you run a scoop command, I didn't know this up until I sat in a worm a couple months ago. But whenever you run a scoop command, apparently what happens is it generates a jar, and then it sends that jar over to the Hadoop cluster. And then the Hadoop cluster will perform the work. Well, we ran into a situation where one of our teams that works next to us was using our ETL engine, and they were trying to load 20 tables on an hourly basis in from a source system from, I think it was Oracle, into Hadoop, and then from Hadoop into our data warehousing platform. And they came to us and they said that they could only get their jobs to work if they ran them in a sequential fashion, which it didn't make any sense to us because we run all kinds of processing parallel, especially scoop jobs in the morning. So what happened was, if you specify a certain set of variables with scoop, it'll generate a generic jar file. Excuse me. It'll generate a generic jar file. And then whenever the next job comes in and you've got it set up exactly the same way, it'll generate another generic jar file. And if you're unlucky and both of those jobs are running on the same compute node, you'll have just overwritten the previous jar file. And the first jar file, the first job, will give you a null pointer exception. This had been happening to us for, I don't know, 2 or 3 months, and we've been noticing it, but it didn't happen very often to us, so we never really understood what the problem was until we ran into this issue. So for us, from a Hadoop perspective, it's important to understand your execution flow path. Authentication has been very challenging for us, especially since we Kerberized our Hadoop cluster. So we've been having a lot of problems with AD and Kerberos. And then finally, and most importantly, resource contention. So one of the things I talked to the team about is make sure you're a good citizen on the platform that you're running on. So in other words, make sure that whenever you're running a process, you're not affecting someone else. And if you're running on a box and something's not working the way you expect it to work, make sure you know if someone else is impacting you. From a data engineering perspective, we focus a lot on making sure the business logic is in the data layer. If we can put the business logic in the data layer, I can take that data and port it to any other platform that I need to based off of use case, as well as move as much processing as possible in the MPP. This is common sense now, but whenever we started out in 2009, we tried to put as much processing as possible in our COTS data integration solution, and we were running into a lot of performance issues. So we switched to from an ETL paradigm to an ELT paradigm about 4 years ago. From a process perspective, reevaluate your assumptions on a periodic basis. What I mean by this is we've had a lot of very smart developers come into our shop and build out a design, and then other developers will continue to work on that design on a go-forward basis. So what happens is you get into a prisoner's dilemma type scenario where some very sharp developer decided on a MART design, and a year later, folks are continuing and progressing on that design and working forward with it, when they didn't realize the design decisions that developer made based off the constraints they had at the time, and 6 months or a year out, those constraints are no longer valid. So for us, it was important to really reevaluate assumptions. One of the things that we had with that scale was our original MART design was a single MART. And so whenever we added a metric to our MART, it added linearly some additional time to our batch process. So recently, what we've done is we went to a multi-fact MART design, and that's helped us parallelize. So even though we were moving to Hadoop to get to a scale-out solution, we actually ended up with a scale-up solution because of the way we defined our MART. And then finally, the concept of a team interrupt has been helpful for us at times. So we have, at any given time, we'll have a pair of developers that are working on trying to build out tools to make our lives better on a go-forward basis. So they're working kind of like Skunkworks and trying things out that they normally wouldn't get an opportunity to do. And so if an issue of the day pops up, that issue will go to that pair, and what that allows us to do is not interrupt the rest of the team that are working on features that we've promised to our end users or committed to for that iteration. So that comes to the end of my talk. Home Depot is transforming from the inside out. Home Depot has a recognition that that a lot of our transformation is based off of software delivery and software engineers. So if you guys know anyone that's in the market, I would be happy to speak with them, or they can go to careers.homedepot.com. We have offices in San Francisco, Austin, Dallas, Michigan, and our headquarters is in Atlanta. So thank you very much, and if you have any questions, please let me know.
I think I need, there you go, it's working. There you go. Amy, before you give that question, I'm going to give you a t-shirt for being the first person to ask the question. So go ahead, ask your question, I'll go get you a t-shirt.
Thank you. My question is, when you do the Hadoop process, your team member is new. How about the learning curve? Is that how long it take to training the team member? And then, sorry, I have to ask another question is, what kind of methodology you take? Is that agile or waterfall or wagile? It's combination?
Yeah. So both good questions. So the ETL engine that we built, we're able to bring in interns and have them build ETL jobs on Hadoop in a matter of a couple of weeks. So we've abstracted the complexities behind the scenes. And also, we have standardized templates for certain types of jobs. So for example, if a job requires a CCD table, we are able to, we have a code generator that will actually, so you insert the name of the database, you insert the name of the table, we'll go interrogate the table, we'll go interrogate the database, we'll figure out the data types, and then we will pre-generate another job that will build out the underlying infrastructure that you need on Hadoop. What I mean by that is it'll build out the directory that you need on Hadoop from an HDF perspective, and then it'll define the DDL for your Hive table. It'll then take that information that it collected and then pass it through and replace variables in the template graph that we built. So you have starter code from the beginning. And it takes, so if we have 40 tables and you point it at a source system, you could have template code in a couple of hours. So that doesn't mean you're done, but what it means is you have a starting point, and from there, certain jobs may work out of the box without any type of change, and then and other jobs you might have to start tuning. And your second question was?
Development methodology.
So we use XP, Extreme Programming. So we do paired development. It's been very helpful for us. So there have been situations where we will have, the developers will tell us where, sometimes before they'd be working on a problem, they would run into issues and they might stall out, whereas if they have another person working with them, they find that they get stuck less often. And if something requires a lot of thought, we might do a mob session. So recently, we had a pretty big push to have everyone do TDD, and it was difficult to kind of get over the hump, so we got everyone together and we did a mob session to build out a data service from to kind of help enforce test-driven development.
All right, walk over. One sec. We can't hear you, one sec.
Sure.
There you go.
Is your Hadoop in the cloud, or is it kind of on-prem, and how are you managing your scaling?
Sure.
That's been your constraint to start with. So.
Sure. So we have 3 Hadoop clusters. They're on-premise. We have a cluster dedicated to batch. It's a 400-node cluster. And we have we have another cluster for ad hoc workload, and analytics. So we do our data integration, the ETL portion or ELT portion on the batch cluster, and we'll dis-CP it over to the analytics cluster. Now, from a workload management perspective, we're given, we're given a certain amount of memory available to us on the cluster for containers. So for us, for our user that we have, we purchase 20% of the infrastructure on the box, so we get 20% of the cluster available to us. That doesn't always work from a workload management perspective, so we have logged in and seen that there was another batch user that came in and took resources from us, and I think theoretically it's not supposed to work like that, but we've seen that happen. On our analytics cluster, where we have at scale running, we barely are using the cluster.
Okay. And the other question is, is there a data movement between these clusters that you're talking? Like, okay.
Yes.
And how is the performance when you're doing this cluster to cluster?
Cluster data movement? Yeah. I've never seen an issue with it. So from whenever we build out our data marts for at scale, which is just a very small use case, it takes about 10 minutes. It's not, so we take terabytes of data and then we boil that down to, tables that are 30 and 50 million records in size, so it's not very big I would say it's maybe a small to medium-sized data problem. Whenever a table gets past 500 million records or a billion records, we'll consider it a big table.
We have time for one more question. So this gentleman here has this question. However, we're going to stick around. We're actually going to go to the booth with Hiren. So two things could happen here is one, you're going to get a free shirt like Amy just did because we're printing shirts at the booth, I believe, still. And if you have more questions, we can handle them here. So let me take your question, sir.
Okay. You said you have mainframes.
We do.
What kind of data that you have on the mainframe, and do you move the data from mainframe to Hadoop? And if so, how?
Sure. So we do have a mainframe. The mainframe, I think the guy spoke about it yesterday. The mainframe has 80% of the transactional data. Nothing's changed. The mainframe has 80% of the transactional data, and we're building out Java applications. To answer your question, what we do to get data off the mainframe is we use Scoop with a single mapper. So the mainframe doesn't, from our perspective, the mainframe doesn't partition its data. And so since it doesn't partition its data, if you use more than one mapper, you're doing full table scans twice, and our DBAs don't like that. So Scoop with a single mapper, unless we get permission to use more. And we also use CCD tables. So whenever we're bringing in data from the mainframe, we're pulling it in on an hourly basis, wherever possible, and then we're cleaning up those tables behind the scenes.
So it's coming from the mainframe database,
DB2. Yep, mainframe database.
All right, I know this is not a great thing, but I do have to close because they've got another session coming. So thank you very much, Hiren, again for this. Thank you for everybody for joining us. And see us at the booth 102 for more t-shirts and more answers to your questions. Thank you.